Hello, my name is Garrett. I work as a business developer for e-Highway at Siemens Mobility, located in Erlangen, close to Nuremberg, Germany. Welcome to my humble contribution to the ninth workshop on sustainable road freight of the University of Cambridge. Many thanks to the professional organizers of this great event for accepting our abstract and, of course, for the opportunity to speak here today. My following presentation is about reaching climate goals by the help of introducing electric road systems based on overt catenary contact line for dynamic charging of electrified heavy goods vehicles or lorries. The EU and the United Kingdom are committed to achieving climate neutrality by 2050. This is still 28 years from now, and it seems to be a far future, but to achieve this very challenging goal, it requires a fundamental transformation in all sectors of the country's economies. And this has to start now, specifically for the transport sector, which is the only large sector with rising greenhouse gas emissions. For heavy and long-haul road freight, different zero-emission technologies are being tested in many countries. And although no clear winner has established itself, the following prerequisites are likely to provide the basis for continent-wide implementation of zero-emission trucking in Europe and beyond. This is first, maturity. A high technology readiness level, TRL, to be achieved through pilot deployments flanked by transnational agreements on normative issues to enable cross-border transports and interoperability. Second, scalability. Quick and large-scale implementation can be ensured by a broad group of industry actors, both infrastructure and vehicles, and with a secure supply of sufficient raw materials. And finally, robustness. This means strong business cases tied to an efficient use of energy from renewable sources, which then would give the associated private and/or public investment plans the necessary level of resilience and credibility. Only then a rapid market ramp-up and penetration can be achieved. The technology for dynamic charging, or lorries, or e-highway as we used to call it, was initially tested on a private road 12 years ago. And over the past decade, a system has been designed, developed, tested, and demonstrated. And since 2016, it has been used on public motorways by regular trucking companies in their daily operations. Currently, there are 3 field trials in Germany, including 8 trucking companies and 15 trucks, with 7 more to come and expected in the field trial near Frankfurt. The operation and maintenance of the infrastructure has been integrated into the regular operations of the road owner. We therefore consider the TRL as very high. And here there are some short films about these field trials available on YouTube, which I recommend watching to better understand how the system works, how it's like using it, and how it fits into the already existing infrastructure. My technical colleagues and systems engineers have been working on a coherent standardization strategy pursued by our company for several years now. And this involves a long-term, step-by-step integration of the e-highway system into existing and emerging standards from the fields of energy, vehicle, and rail technology. From the sum of the subsystems, we want to gradually advance a normative anchoring of the overall system, precisely because standards have a long period of validity. And practical work results and ongoing work for individual technical specifications for the most important interfaces of ERS flow into the implementation, for example at Senelec and the German Association for Electrical, Electronic and Information Technology, abbreviation is DKE. Individual activities for the subsystems are placed into the larger context of electromobility and the Electrified Road as Standardization Initiative. And this will initiate or intensify European harmonization where necessary. As a result, these 2 draft technical specifications, to be seen here on the slides, have been submitted in mid of this year, and we are confident to seeing a publication towards the beginning of next year. To bring this forward, a working group of ERS was established within the DKE to promote technical exchange and cooperation between the groups for electrical equipment for railways and electric road vehicles. And this helps and supports to identify relevant interfaces and to transfer international standards. In a first step, the working group, which is led by Siemens Mobility, is examining the different protection concepts from the railroad and automotive worlds. So how could this further evolve? Thanks to the railway sector, there is already a market for supplying traction power substations, cables, poles, and catenary wires. Alone, this business volume accounts to roughly 10 billion globally per year. So that ensures there is broad industrial base that can be leveraged to supply road electrification projects. Installing OCL on roads also has an advantage over today's railway applications. All OCL trucks have onboard batteries, which means the OCL doesn't need to cover the entire distance from A to B, which makes implementation faster. Overt catenary has been built for more than a century in almost every country, with established regulation in place and expertise by many companies. And studies already show how commercial OCL could work on shuttle routes of about 100 kilometers in length. As already demonstrated, these initial routes can be used by both battery electric vehicles, or BEVs, without large batteries, and by hybrid trucks. Minimizing the need for large batteries helps ensure that the transition to electrified transport can go smooth as fast as possible. Furthermore, ERS could also make less energy-dense battery chemistry attractive, which would potentially eliminate the need for raw materials with a fragile supply chain. Now, if we have a closer look at the potential zero-emission technologies for trucks, it is evident there is no clear preferred option, as every technology has its pros and cons. Hydrogen trucks with a fuel cell and a buffer battery on board potentially provides a good use case for long-range transports where electrification is not economical. And pure battery electric, the so-called BEV trucks, have had steep rise already following the success with electric passenger cars. All major manufacturers are launching BEV trucks, including 44-ton versions, albeit with ranges so far well below 500 km on a charge. Hybrids with an electric drive and a combustion engine for synthetic or biofuels can make use of the available fuels infrastructure. However, these fuels face high demand from different means of transport in aviation and agriculture. The concept of hybrid vehicles could help OCL overcome the so-called chicken and egg problem, since they will be able to operate across Europe right from the start. In other words, without having comprehensive infrastructure network in place. Built on early shuttle routes, an OCL infrastructure can serve as an energy backbone and boost the aforesaid drive technologies. The OCL infrastructure also can be built out gradually and with power levels increased as the numbers of users grow into a national and continental network. Siemens has a partnership with Continental Engineering Service for the industrialization of the pantograph, so it can be mass-produced and fitted on the electric trucks from any manufacturer. Several studies and plans from across the EU and the UK show that direct electrification of heavy road freight is the most energy efficient and therefore also the most economical solution. And given the recent price rises of imported energy, which also pushed up electricity prices, this factor has only grown in importance and can remain crucial going forward. And not only to our view at Siemens Mobility, a combination of stationary and dynamic charging offers the best mix in terms of strength of each technology. Both of them are the most mature and efficient solutions and complement each other use cases strongly. While high-power chargers can provide a broad and quick geographical coverage, dynamic charging could ease the scaling up on more core corridors where space is scarce and there is no time lost for charging. Now, with my last slide, I'd like to refer to what the German government has concluded. Dynamic charging via overt catenary is the only relevant ERS option for HEVs. In parallel, neighboring countries as the Netherlands, Denmark, and Austria have started an ERS deployment needs to be coordinated with a large neighbor, who is also the most prominent transit country for European road freight. So in 2020, the German Federal Ministry has published a comprehensive concept for commercial vehicles to reach the overall goal of 1/3 electric mileage or ton kilometers already by 2030. Among BEV and fuel cell trucks, OCL was chosen as the third element. And last year, the ministry announced 3 projects for testing out the most promising technologies for zero-emission trucking at larger scale. 2 of them consist of overhead catenary in combination with BEV and fuel cell trucks. The ministry furthermore set up a task force for dynamic charging for OCL to what needs to be done for a next step. On the lower right side, here, you can see the target image. Unfortunately, it's a bit small here, but it has got 4 main areas, like the route network, the energy grid, the charging options, and operations and further options. So last month, on this year's annual conference on climate-friendly commercial vehicles, the Federal Ministry has published its progress report. And data of truck manufacturers clearly show the forecasted truck sales figures will increase sharply in the next years. By 2030, 75% of all newly registered trucks from 12-ton gross weight onwards shall be emission-free. The ramp-up of an initial zero-emission charging infrastructure is largely supported by the ministry, starting with first tenders already in next year. The realization of innovation clusters with overhead catenary is being examined. And with that, I would like to end my presentation here. Thank you very much for your interest and your time. I hope you have enjoyed it and there were some interesting aspects for you in. Goodbye and hope to seeing you in person in Cambridge very soon.